Hi Vanessa, I wanted to give you some feedback on your assignment, so I thought we would do it by video. I'm just going to go through each question and let you know how you did, and if there's any corrections, try to explain what I was looking for here. So for question 1, starting up here, that one's great. You did the synthetic division, and most people prefer that over the long division, and you ended up with the remainder of 9. That's perfect. Now, looking at question 2, in order to find the x-intercepts, I don't know if you were using a program, a software program, a graphing calculator, or how you found the intercepts with the decimals, but what I'm looking for there is the intercepts to be given as fractions or whole numbers, and the way that you would determine those would be to start with the original function, f of x, and do what you did in question 1. So I want you to factor it using factor theorem. You can start with synthetic division and find the first root, and then you should have a quadratic to factor after that, and that should give you your 3 roots. So x equals minus 1 is certainly an x-intercept. When we write x-intercepts, we should write them as minus 1 comma 0 as a point. If we're going to refer to them as roots or zeros, we can just use the value. This one here, it looks to me like what you got was a 2/3 value for x, and this one here should be a 3/4 value. So if you go back and try factoring that to find the roots, I think you're going to find those fractional. What you'll end up with is a bracket like 3/4 would look like this in your bracket. You would have 4x minus 3, and that gives you a root of 3/4. You take the 3 and divide by the coefficient of the x. Question 3 looks great. Everything was perfect there. And question 4, I just want to talk to you a little bit about writing your domain or your solution in an interval notation. And the universities now, what they're expecting is, instead of us writing it in this way here, they're looking for us to write it in what's called interval notation. And I'm not sure if you've been taught that or seen it before, but what it looks like, it's quite simple once you see it. What it looks like, I'm just going to give you an example over here. Let's say that we wrote this as our solution for x. That would mean that x lies between 1 and 3, and the round brackets would tell us that x is actually greater than 1 and less than 3, but not equal to. If I wanted to write something where I actually had those end values, let's say I had minus 1 comma 8, and these values don't pertain to this question at all, it's just an example. This would mean then that x is greater than or equal to minus 1 and less than or equal to 8, and so we include the values of minus 1 and 8 in our solution. So when we're writing for A and for B, I'd like for you to use the interval notation. You've done your number line correctly, and you've determined with the range of the x values that satisfy the equation. That's great. So if x lies between, or if x has to be less than or equal to minus 1, the way that we're going to write that, and I'm running out of space here, so let me just write it above, is I'm going to use a round bracket, and I'm going to start at minus infinity, because that's the smallest number we can possibly have, and I'm going to write comma, minus 1 square bracket to show that the minus 1 is a value that x can equal. For x is greater than 2, the way I'm going to, or greater than or equal to 2, I'm going to show that as a 2 with a square bracket, because x can equal 2. And anything greater means I can go all the way up to positive infinity there, and so I'm going to use a round bracket after the infinity because it's not a real value, so we can't ever sort of land on that value, so we always use the round brackets for infinity. So that's what I'd like to see you do whenever you're asked for a solution where it's going to be a range, such as inequality, or whenever you're asked for domain and range for a function. I like for you to write it like that because that's what you're going to be expected to do at university, and so it's a great habit to get into. I'm just going to switch over to the next page. Here we go. And go over some of these questions with you. Okay, so everything looks really good. You did a great job on this page, and you're showing a really good understanding of the factor theorem and the remainder theorem and the ideas behind it. So that's excellent. So this one's great. This one's great. You did this one correctly, and the only thing that I would point out here, and again, I'm just thinking forward because the functions is really a preparatory course for, first of all, the calculus, obviously, but people who are taking functions and calculus in high school are definitely heading for a university level math course at some point in their lives. And I also teach at Trent University here in Peterborough, so it gives me a real advantage because I can see exactly what students are expected to do at that level. So I like to prepare students as much as I can to be doing those things already. For number 7, the only thing that I'm going to point out there, and it's not a major thing, it's just that there's a difference between a factor and a root or a zero. And here you've got them reversed because if we substitute a into this equation, we get a remainder of 0. It tells us that a, or negative a actually, is a root, and x minus a is a root or a 0 of the equation, and x minus a is a factor. And so we've got the factor and the zeros transposed here. It should be the other way around, and so it's just an important understanding. Especially if you are asked to find one or the other, to make sure that you understand which is which there. All right, so number 8, everything's great there, and number 9, everything looks perfect. So you did a really good job, and you're showing that you have a really, really good background in this, and that's a really important thing, especially in calculus again. When you go to the curve sketching unit, you're going to have to factor higher level polynomials in order to find the roots and finding the zeros and the turning points and things like that. And so having a really good background like this and strengthening your skills is only going to help you for sure in the calculus course when you take it next year. All right, great work, and you're making really good progress in the course now. I'm really happy to see you moving through it so quickly. Don't hesitate to call me, email me whenever you need help, okay? Thanks.